One topic in indirect volumetric method analysis is indirect volumetric method. So in this indirect method, we make use of a Keldal method to determine nitrogen in organic compound. So these are the steps involved here. The sample is digested with concentrated sulfuric acid. So it is digested with concentrated sulfuric acid with a certain catalyst. So nitrogen in the material is converted to ammonium bisulfate. So the nitrogen will react with sulfuric acid, or the ammonia will react with concentrated sulfuric acid to ammonium bisulfate. So the nitrogen is now converted to ammonium bisulfate. And the resulting solution is made alkaline with NaOH. So the liberated ammonia now, which is a gas, will be distilled through condenser into a measured volume standard acid. So the ammonia plus hydrogen will produce ammonium ion. So the acid remaining in the receiving flask after all the ammonia has been liberated is titrated with standard sodium hydroxide. So our objective here is to determine the percentage nitrogen in the original sample. Okay. So if you're going to determine percentage protein, for example, you're going to multiply the percentage nitrogen by 6.5. This is 6.25. This is what they use in determining nitrogen, for example, in meat, or determination of protein in meat or dog food, for example. That is one use. Okay. So calculation is made by determining the total number of milliequivalents of the reagent added and subtracting the number of milliequivalents used in titration. So the difference in the number is the number of milliequivalents of the desired substance. So we're going now to get the net milliequivalents. That is the difference in the number of milliequivalents of the desired substance. So what would be the reactions involved here? First, we're given the normality of HCl. So milliequivalents now of ammonia. So since we're given the amount of ammonia, milliequivalents of ammonia, how can we determine that? So milliequivalents of ammonia is equal to milliequivalents of HCl. So that is milliequivalents of the acid is equal to milliequivalents of the base. This milliequivalents of HCl should be the net milliequivalents. So where can we determine the net milliequivalents? So milliequivalents of HCl is equal to normality times the volume. So normality times the volume of HCl. So how can we determine now the milliequivalents of sodium hydroxide? Because the net milliequivalents now would be net milliequivalents would be equal to of HCl would be equal to the milliequivalents of HCl used minus the milliequivalents of NaOH. So we can easily determine the milliequivalents of HCl by multiplying normality times the volume, and that would be equal to, what is the normality of HCl given? 0.2520 normal times 25.0 ml. So the milliequivalents of HCl would be equal to 6.3 milliequivalents. How about the milliequivalents of sodium hydroxide? Again, we're given the volume and the normality. So normality times the volume would be equal to 0.2340 normal times 2.75. And we will get here, that is in ml. And we will get here a value of 0.6435 milli equivalents. Now, to determine the net milli equivalents, that would be equal to milli equivalents of HCl, which is 6.3 minus 0.6435 milli equivalents, and that would be equal to 5.6565 milli equivalents. Now, we have go back to the first equation. So in this first equation, milli equivalents of ammonia is equal to net milli equivalents of HCl. We are after the percentage nitrogen. And the source of nitrogen, since in the neutralization process, its ammonia reacts with hydrogen ion, one hydrogen ion, to form ammonium ion. And since its ammonia is now converted or derived from one nitrogen. So this is derived from, ammonia is derived from nitrogen. Okay, yes, one nitrogen. Okay, so how are we going to solve this? Wait, now, we do not have any data for ammonia. So we make use of this formula for mole equivalence. Weight of ammonia divided by molecular weight of ammonia factor times 1000 is equal to net milli equivalents of HCl. And what is the weight of ammonia? It is unknown. Weight of ammonia divided by molecular weight of ammonia is 17 grams per mole. Simplifying these values class or this term, it will be placed in the numerator. So what is the factor of ammonia? It will be converted to ammonium hydroxide, one replaceable hydroxide ion. So the factor is 1 equivalents per mole. What would be the factor? Times 1000 equivalents, milli equivalents per equivalents. Okay. Is equal to the net milli equivalents of HCl, which is 5.6565 milli equivalents. And you will get here a value for the weight of ammonia, which is equal now to 0.0962 grams ammonia. Okay, now, our objective is to determine the percentage of nitrogen. So as I've said a while back, in the neutralization process, its ammonia reacts with hydrogen ion to form ammonium ion, and its ammonia is derived from one nitrogen. Okay, to determine now the weight of nitrogen, so that we can determine the percentage of nitrogen, we now get the weight of nitrogen. What is our source? From ammonia. So we have 0.0962 grams of ammonia. Convert this to moles of ammonia. So in converting from one substance to another substance, if you're given the weight, convert it first to mole of the given substance, then to mole of the desired substance, and then multiply it with the atomic weight or molecular weight. So to convert to moles of the given substance, so that is moles of ammonia, then the denominators should be in grams of ammonia. And what is this? It is the molecular weight. So divide it with the molecular weight. 1 times 17 grams of ammonia, we have now moles of ammonia. And how many moles of nitrogen in 1 mole of ammonia? We have 1 mole of nitrogen is to 1 mole of ammonia. So you have to show this relationship even if the value is 1 is to 1. So 1 mole of ammonia, you have to show the conversion from ammonia to nitrogen. Then multiply it with the atomic weight. Atomic weight if it is an element. 17 grams of nitrogen is to 1 mole of nitrogen. So this is now the atomic weight of nitrogen. Okay. So we can now 14, sorry, that is 14 grams. The atomic weight of nitrogen. So we can now determine the weight of nitrogen. Weight of nitrogen now would be equal to 0.0792 grams. What would be the percentage nitrogen? Percentage nitrogen would be weight of nitrogen divided by the weight of the sample times 100. Okay, so that would be equal to 0.0792 grams divided by the weight of the sample, which is 1.0 grams, times 100. So the percentage nitrogen would be 7.93%. As I've said, if you're going to determine the percentage protein, just multiply this value with 6.25.